All right, gang. So the goal for this week is to introduce how we can evaluate trig functions without a calculator when we've got angles on the unit circle. So let's take a look at the diagram, and we're going to set this up. You're going to be able to evaluate sine, cosine, tangent, and the reciprocal trig functions, cosecant, secant, and cotangent, all by hand without a calculator. And this is going to incorporate some things that we know about special right triangles, things that we know about SOHCAHTOA. So let's take a look. All right, so I have drawn a unit circle. And something you should know about a unit circle is that the radius is 1. So that means I actually know the distance between the origin, the center of the circle, and any point on the edge of the circle is 1 unit. That means this distance here is 1. So let's say I pick some angle in that circle. And what I've done is I've just started simple. And I've created an angle that has an initial side on the positive x-axis. That's where the initial side always sits. Initial. And a terminal side right here. This is the terminal side of the angle. So initial side to terminal side, that rotation there produces an angle. It's in quadrant 1, it's acute. I'm going to call that angle theta, right? I don't know how many degrees that is, but I'm just going to name the angle theta. So I can actually figure out the sine, cosine, tangent, cosecant, secant, and cotangent of that angle if I know the radius of the circle and the coordinates of this point here. If I can figure out the coordinates of this point, the xy coordinates, knowing x, knowing y, and knowing the radius will actually let me evaluate all of these things. All right, so let's draw a right triangle in this diagram, right? Because everything we know about trig up to this point has hinged upon finding right triangles related to SOHCAHTOA. So if I take this point here where the terminal side crosses the unit circle and I drop an altitude to the x-axis, I create a right triangle where one of the angles in the triangle is theta. That's actually my central angle coming out from the center of the circle. I've created a right triangle here, and what I'm going to do is I'm actually going to take that triangle, I'm going to project it over here. So that triangle is showing up in 2 places. It's in the unit circle, but it's also over here. And let's think about what we know about this triangle and maybe what we could label on this side. So I know the hypotenuse. I know the hypotenuse is 1, because that's the radius of the circle. Let's think about what else we know. We may not know actual numeric distances, but we have some representations for some other lengths on this triangle. We actually have a representation for this length and for this length. Now think back to the diagram. In order to get to this point here, which corresponds to this point of the triangle, think about how we go from the origin to that point. I have to go over x amount of units and up y amount of units. This distance is x, this distance is y. Now as it stands on this triangle, I don't necessarily know the lengths of x and y, but I have representations for them. X being the horizontal distance, y being the vertical distance to go from the origin to that point. All right, well here's what I want to do. I want to think back to what we know about SOHCAHTOA. Now, given this right triangle, I could actually figure out the sine of this angle, and the cosine of this angle, and the tangent of this angle, using what I know about SOHCAHTOA. So sine of an angle in a right triangle is the opposite over the hypotenuse. Sine of this angle is the opposite y over the hypotenuse 1. And I want you to think back to what did 1 represent? 1 is the hypotenuse in that triangle. It's also the radius. So I'm going to call this r for now. I know the radius of the unit circle is 1, but let's be a little more general. Let's just refer to that as the radius. Sine of this angle is opposite over hypotenuse. It's y over r. So the sine of theta is whatever the y coordinate is on the unit circle divided by the radius. Let's look at cosine. Cosine of this angle is the adjacent side over the hypotenuse, right? So x over r. Cosine of theta is the x coordinate on the unit circle divided by the radius. And finally, tangent. Tangent is opposite y over adjacent x. Tangent y over x. All right, so we've now got some general formulas for how we can find sine, cosine, and tangent for any angle on the unit circle, as long as we know the x-coordinate, the y-coordinate, and the radius. All right, well now what about the reciprocal trig functions? Well, remember, cosecant is the reciprocal of sine, and reciprocal means you flip those things. Therefore, cosecant of theta is r over y, radius over y-coordinate. Secant is the reciprocal of cosine, it's r over x. And finally, tangent and cotangent, they're reciprocals. Cotangent of the angle is x over y. So if I can figure out the coordinates of these points, and I can figure out the radius, or I know that the radius is 1, given that something's a unit circle, you can evaluate sine, cosine, tangent, cosecant, secant, and cotangent. You can evaluate all 6 trig functions, and you can actually do it without a calculator. The without a calculator piece is going to rely on what you know about special right triangles, 30, 60, 90, and 45, 45, 90. So check out those next few videos so you can get a better understanding of how this relates to special rights put on the unit circle.